My name is Ben Calculus. 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 My name is Ben Calculus.
Hello and welcome. Today we are going to be solving the fifth question of the 2010 Calculus BC FRQ. This question asks us to consider the differential equation dy dx equals 1 minus y. Then let y equal f of x be the particular solution to this differential equation with the initial condition f of 1 equals 0. For this particular solution, f of x is less than 1 for all values of x. Let's get started with part A. So part A asks us to use Euler's method, starting at x equals 1 with two steps of equal size, to approximate f of 0. And we need to show the work that leads to the answer. So our first x and y are 1 and 0, and our first slope is going to be dy dx equals 1 minus y, evaluated at y equals 0, and when we plug 0 in, we get 1. And our next y is going to be when we use point-slope form of these points with our new slope of 1, and we evaluate this at x equals 0.5. We plug in to get negative 0.5 as our next y value. So now our new x1 and y1 values are going to be 0.5 and negative 0.5. Next, we're going to find our second slope, which is dy dx of which equals 1 minus y, evaluated at our new y value of negative 0.5. And when we plug that in, we get 1.5. So now we can find our second y value, and using point-slope form with our slope of 1.5, we can solve by plugging in y of 0 and getting 1.5 times negative 0.5 minus 0.5, and getting our final answer of negative 1.25. Now on to part B, which asks us to find the limit as x approaches 1 of f of x over x cubed minus 1. Now you may notice that this is a L'Hopital's rule problem, because f of 1 is 0, and x cubed minus 1 when x is 1 is also 0. So we need to show the limit of the numerator and the limit of the denominator. So we take the limit as x approaches 1 of f of x, which is f of 1, and we know that that is 0. And then we take the limit of the denominator, which is x cubed minus 1, and that just becomes 1 minus 1, which is 0. So we can box those off as our justification for using L'Hopital's. And now when we use it, we get the derivative of the top, which is going to be f prime of x, over the derivative of the bottom, which is 3x squared. And remember, you can't do 0 over 0 for justification. You must show the limit of the numerator and the denominator separately. And now f prime of x is going to be the dy dx evaluated at 1, 0, and all over 3, because 3 times 1 squared is 3. So we get 1 minus 0, which is our y, over 3, which equals 1/3. So part C asks us to find the particular solution y equals f of x to the differential equation dy dx equals 1 minus y with the initial condition f of 1 equals 0. So we can write out that differential equation, and when we divide both sides by 1 minus y, we separate our variables so that we can integrate both sides. And after we do that, we get negative natural log of 1 minus y absolute value, equals x plus c. And we only need one c because the c from this side could simply be added to this side. So now let's move that negative over. We get natural log of absolute value of 1 minus y to equal negative x plus c. And since the c could be positive or negative, we can just leave it as a positive. So now if we raise both sides to the e, we get absolute value of 1 minus y and equals e to the negative x plus c. So since f of x is less than 1 for all values of x, this is always going to be positive. So we can just get rid of those absolute value signs. And we get 1 minus y equals e to the negative x plus c. And then we can rearrange this to be y equals 1 minus ce to the negative x, because we can bring that c down. And when we plug in our initial condition f of 1 equals 0, we can then solve for c. Ce to the negative 1 is going to equal 1. Therefore, c must equal e. And therefore, y equals 1 minus e times e to the negative x. And so our final answer is 1 minus e to the 1 minus x. Now let's grade our work. When we look at the first problem, we see that College Board used a delta x term and fractions instead of decimals. But these still yield the same answer, and there is still Euler's method with 2 steps, so we will collect both points on this problem. Part B is also worth 2 points. The first point is for the use of L'Hopital's rule, which we did here, and the second is for the answer of 1/3. Since we got both of these, we will collect 2 points on this problem. And now for our final problem, which is worth the majority of points of this FRQ. So the first point is for separating our variables, which we did here. The second point is for taking the antiderivatives of these, which we see here. The next is for the constant of integration plus c, and as you see, there is only one. You do not have to put one on both sides. In fact, you're not supposed to. The next point is for using the initial condition, f of 1 equals 0. So here I used it at the end of my solving process once I had already isolated y. And here they used it early on, before they had isolated y. Both of these are valid ways to solve it. The only thing you can't do is find c early on and then plug it in later, or vice versa. Our final point is for solving for y, which we get is 1 minus e to the 1 minus x. So you can lose a lot of points here if you forget your plus c. They will not give you follow-through points if you forget it. And you will lose all 5 points if you don't separate your variables. So remember, when you see solutions to differential equations, you must separate the variables. Otherwise, you could lose all 5 of these points. Thanks for watching. Please leave a like if you found this video helpful. If you have any questions, please comment below. Otherwise, I'll see you in the next one.